Our first speaker today is Jeremy Frey of Southampton University. Jeremy is joining us remotely from Southampton, and he will be speaking on Science Ajar, new ways to collect, curate and share information. Jeremy, nice to have you with us. If you would like to start your presentation, that would be great.
Thank you very much. Thank you very much. Thank you for the opportunity to give this talk. I think this is actually the first time I've given a talk in such a remote way, and particularly from actually at home due to some weather issues. I'm very happy to talk to you about what I call Science Ajar. That the idea there is to indicate the sort of level of openness that everybody at least should be adhering to, all the way through to our very respected colleagues who are prepared to do their science completely in the open. And one of the things that I really want to talk about through the talk, and that's why I put collect, curate and share information, is actually what sort of information are we trying to share. And one of the lessons I hope that will come through from the collaborations that I'll talk about is it's the quality of the information, the data, the context in which that data was created, the processes by which it's created is as important as the data itself. And I want to try and show you how we've gone about trying to do that within our own projects. So I'd have the next slide. I'll tell you something about my experience over a number of projects that I've been involved in the last 10 years. And in some ways where there's been an increasing move to openness, especially with research data, to facilitate these collaborations. So even if we don't make it available openly right at the beginning, we certainly have to make it open and shareable within some very large research teams. And what I'll also talk about in particular is how the eScience program in the UK that I've been involved in and the work we've done with semantic web and other technologies has helped us achieve this game. And in general, talk about the social versus the technical challenges and the rewards, because by no means are all these issues by any means technical, though there are enough technical issues. A lot of it is social. If I have the next slide. So one of the experiments that I've been involved in now almost for 10 years, and actually it's almost working, just to give you a little bit of background to one of the areas that I'm working in, so that you can see I am actually sort of still a card-carrying chemist and physicist, is the use of soft X-ray technology generated in the laboratory, in fact generated from lasers, so it's a particular type of coherent X-ray microscopy, to look at, in the end, biological objects and materials in a way that's quite different from sort of electron microscopy or other techniques that are available. And there are a number of technical advantages to using soft X-rays, but there are other disadvantages in the difficulty of dealing with this. If you can press forward the next slide, or at least the next overlay, I'm not sure if it will come yet. This, just to give you an example, we started from a largely bare lab less than 10 years ago and now built up a long complex piece of equipment. Just to give you an idea of the focal point of one of the research collaborations here, because I'll distinguish between collaborations that are based around some piece of equipment and collaborations that are rather more distributed. If the next slide. See, in particular, just to indicate why computation is so important in this experiment, it's not just the lasers, but those of you who may be familiar with X-ray crystallography will be aware that when you record a diffraction pattern, a Bragg scattering pattern from a crystal, you get the intensities, but you don't know what the phases are. So you're missing some information needed to reconstruct your crystal. Well, the same is true in the imaging that we do here, but it turns out quite remarkably that as long as you're careful and collect, in a sense, rather more data than you should, then it's actually possible to work out computationally, rather long and involved computation, to work out what the phases are to reconstruct your objects. And though I say long and involved, it was long and involved when it was first started in the 1960s, but if you use one of these GPU processors sitting even in a fairly normal desktop, we can now do this in a matter of 10 seconds, something that would have taken overnight not very long ago. So we can reconstruct our objects. So this project involves laser physicists, chemists, biologists, mathematicians. If you have the next slide. Actually see there some of our reconstructions of a test object, getting both the intensity and the phase out. And the next slide. So when we started this project, because we were going to involve so many people, largely focused in Southampton but not entirely, we needed a mechanism to share and collaborate on information. And we decided that with new students coming in at that stage, they did understand what the sort of social media things were. They certainly would understand what blogs were, so that we would use a thing like a blog to share information, whether that be data that's been processed, data collected, experimental plans, or literature, or planning for conferences. All of that could go in on the blog. Now, at the time, there was no out-of-the-box system that we could use. Perhaps now there might be systems that we could modify, but we constructed our own, making it look like a blog, but it focuses much more around the issues of sharing and controlling that sharing, and around data. So it makes it very easy to put up items of our data and discuss them. And this has actually been key in keeping all the various students, and perhaps even more difficult prospect, keeping all the members of staff who are involved more or less extensively in this project. I have the next slide. And as a planning tool for those of us in charge of this project, the timeline. We use the MIT Similarly software. We're very pleased to see that Facebook started to use timelines, see the value of them. It makes it very easy for us to see what has happened in the past, and send out notes to people to say, what's been going on here, why, if you like, what work have you been doing that you haven't reported yet? Maybe in the future we would extend this timeline going into the future, so that we would actually use it explicitly as a planning tool along the timeline. Next slide. So that just gives an example of us using our software that's developed in the eScience part of my group, and using this in the collaboration based around the lasers. Now, perhaps distinguish a bit between the inter or multidisciplinary research. I mean, is there a difference? Well, one of the problems is that often these things, inter, cross, multi, are used differently by different people. But the essence I wanted to distinguish, perhaps in two of the projects that I was involved in over the last decade or so. One was the eScience project that we call CombiChem. It was combining combinatorial chemistry with sort of eScience, and that involved chemistry, computer science, and statisticians. But whilst there were lots of pairwise interactions, we could to some extent divvy up the work and have the chemists were doing some work, and then the computer science could interact with them and then do some of their own work. The statisticians could help plan at the beginning and then look towards the end. They would be involved all the way along, but we weren't necessarily focused about one central object, one piece of equipment. So it was a distributed collaboration across several sites, but even within one university it was still very distributed. Whereas this laser-based ultrafast soft X-ray imaging experiment that I've just shown you the equipment is very much based around one physical piece of equipment. And although people will do work, the mathematicians might be able to work separately, in the end everything ties back to one physical location. And that has made a very makes a difference to the nature of the collaborations. There is a common space in the second experiment that most people come into, can get hold of, and visualize the experiment. Even if other parts of that, like making the samples, have generated elsewhere, and information needs to flow in to the central place. But it does provide a sort of central hub. Whereas the more delocalized CombiChem was very much sort of a hub and spoke model was not really the way it worked. It was just delocalized. I mean, the extreme of that is then the project that I'm looking after now as part of the UK digital economy theme, and they recently created 4 challenge areas, and one of the ones is IT as utility, and there explicitly we are a network. So this is completely delocalized without so much of a center. The center is just an organizing operation. So these these differences in structure of the collaboration do make a considerable difference to the social nature of the interactions. Have the next slide. So the UK has been involved in lots of discussions over the last few years about open data, and the Cabinet Office reports. I recently visited part of the Cabinet Office, and it's a very interesting locations in the UK, with some very formal civil service parts and some very informal, clearly Web 2 parts. So I think the UK government is taking on some of the digital arena really in a very serious manner. But to some extent, the issue about the open data got confused with the open access. Now, others in the talks will probably talk more about open access, and that to me is an economic argument for how do you get hold of the data. The open data issue is also involved with that, with behind the data behind the paper. But if we can have the next slide. And in fact, the next one after that as well, please. I'd particularly like to introduce the Royal Society report on open data, on intelligent access to open data, because one of the issues that I think that it comes in a sense before the open access debate is, so what is it that you're opening access to? And very importantly for the progress of science is that when you publish some work, you do make the data available on which you manage to draw your conclusions so people can check it and redo it. Now that has problems obviously for some people who wish to take further action on their data, and that has to be considered. But when you make that data available, one of the nice lines in the Royal Society report is intelligent access to the data. I can make my data very open in the sense you can download it all. You may be able to do nothing with it because it's not at all clear what any of it is. That's, how do you hide a tree? You put it in a forest. It's a real problem that needs to be dealt with. And it's fundamental to the progress of science. So economic arguments about open access aside, if you don't actually have intelligent access to the data, open or closed is not going to make you take any advantage here. So there are things that are really fundamental to the progress of science which we need to deal with. And we need to work out how to capture that information. Can I have the next slide? So intelligent open access to data is key here. Have the next slide. So we want the access to the discussion and the means to reproduce the analysis. And there are a number of open science projects that have really pushed this to the limits, and including access to the code and the variations on that have been built into code. You may take somebody else's computer code to analyze your work and then make some changes to it. One really should make ideally that code open. Of course there are problems of scale, and maybe you have the code, you may have no means to rerun it. So there are real issues here. This is not a complete story, never can be. One can just do the best one can. But where it is the means to reproduce, so at least you need to know what process was undertaken. Have the next slide. One of the interesting things that happened in the UK a few years ago saw some of the discussion that was taking place on the climate. That led to a number of difficult issues for UEA and for the community. But fundamentally, one of the things that I thought was rather nice was, given this BBC News report, that the headline there of "Show You're Working." In the end, that's actually what it came down to. Are people prepared to show how they got their results, show the working? Now, as I tell our students, when I was at school, we were always told in an exam, show you're working, because there were more marks for how you got to something than actually the right answer at the end. And especially if you get the answer wrong, you may still get most of the marks for having done the right thing in the right process. So somehow that message sometimes gets lost in our reporting in the literature, where it's the result that is taken. But if somebody doesn't have the full understanding of the context of that result, what it depends on and how it was achieved, they will miss a huge amount when they come to apply that result, and may misapply it very readily without even being aware that there's a problem. So I think this idea of showing your working, showing that context, is crucial to certainly the education of the next generation of researchers, if no one else. And capturing that process and displaying it is one of the things that we try and employ and try and encourage in our electronic notebooks. Have the next slide. So many of the journals were actually very clear about this. If you read the instructions to authors, they make it very clear that you must provide enough information to substantiate what you've made, what you've done. And actually, many of them are very clear that methods are important as the data. And any processing you've done for images and so on should be recorded and be made available for checking. So I don't think this is anything new. The issue is just how much was it honoured. And when maybe one was publishing for close colleagues and only people who were in the know already, maybe you could get away with less description. But now everybody's research is really quite different. They are publishing to a much wider interdisciplinary communities who may not know all the ins and outs and can guess what you must have done. So you have to be very clear about the methods employed. Have the next slide, please. One of the touchstones that I like to point people to is to look at Faraday's laboratory notebooks. They're available in facsimile and the detailed content analysed. What's nice about them is that they contain a lot of detail about what Faraday did, how he planned his experiments, but they contain the magic things about why he did things, the thought processes behind what he was doing, why he thought to do something. And that is really not only interesting to read, but is really informative and educational for those people learning what to do. And I think we sometimes, when we're talking about transferring skills to new people, that one of the reasons why it's so difficult to transfer expert skills is that actually we often don't record the why. Why are we doing something? Why did we decide to do this? And on what basis? And it's actually ensuring we capture that in the electronic notebooks, that discussion that you may have with yourself or perhaps with others in the group, record that down so it can be part of the process of the experiments, taking it forward. Have the next slide. So a lot of the work that goes on when you start mapping this over to understanding the way in which data is coming in and we generate information from it is this famous DIKW diagram. So we hopefully flow up from data, add relationships, get information and patterns, get knowledge and wisdom. And there are lots of nice examples with green and yellow bananas about what goes on there. But one of the things that I like to do is to relate that to how people actually also learn and understand themselves. So I sit in a university, so we have a primary role of educating both the undergraduates but also the graduate students doing the research. And there is certainly a level where you get this data that people remember it, but until you get information and knowledge, you really don't progress up the tree. Okay, I'll speed up a bit here. Okay, can I have the next slide, please? So we want to disseminate the methods, and that we discover varies hugely with the audience that you're dealing with. Different subjects have different ways of and different priorities in dissemination, and indeed in authorships and acknowledgements on the paper. Quite striking how different communities work here, and that's something that one has to bridge when doing an interdisciplinary project. Have the next slide. One of the biggest problems that we have is how to validate the data, because in the past, the good and the great could get together, they knew who had made all the measurements, they could work out what the best results were to take forward. But now this is increasingly difficult to do. We can't get everyone together, they wouldn't, even if you did, they wouldn't know people. And so it's really important to publish provenance and context with your data so that value can be appropriately assessed. So validation is, I think, one of the big things going forward. Have the next slide. And communicating that is difficult. It's very difficult enough when we get two people together. Often we actually do this by sitting them in front of a model or in front of the system that you're trying to describe, and then they understand it. When you're trying to do this globally and there's no way that you can actually get together, the potential for misunderstandings is huge. So again, context is absolutely critical to convey. They do this by models or by detailed descriptions, but context must be carried over with the data. Have the next slide. One of the things that we wanted to make use of in chemistry departments is the idea that we now plan many of our experiments in advance in the UK for health and safety reasons. And if you have this plan in advance, then you can actually use that as a framework on which to hang your description. So this is basically metadata in advance, not metadata tagging afterwards. And this is very powerful when you can use it and persuade people to use it. Have the next slide. And we employed that in our so-called Smart T project, where we used the COSH form as the basis of the planning tool and then had an enactment tool to actually record the experiments as you were going along. Turned out that when we did this about 8 years ago, 7 or 8 years ago, the sort of tablets were a bit clunky, so we've moved away from that. We're about to come back to work on that sort of in-lab tool because iPads and Android phones and so on are getting so much more powerful. I can have the next slide. So just saying plans leads to provenance, leads to high quality data. The next slide, please. So here is just a slide showing that the planning process, you get materials, that gives to a procedure into the lab, and you record things against the procedure. One of the interesting things is how do you record stuff that happens that you weren't expecting? And that's one of the interesting areas of pushing the limits of things like ontologies and the semantic web. How to record against what you thought would happen, what actually happened, because it's the surprises that often can be the most important. Can I have the next slide? What then was important is, by one means or another, you're recording what's going on in the laboratory. You saw the Smart T there was for a synthetic organic lab, but more generally we then developed this LabTrove tool, which is our blog-based sharing and caring tool. So it looks after the curation of the data, it looks after the sharing, images and so on. And one of the nice things that we can do, because chemists love sketching things in a tea room on the back of anything that they can find, is that even given limited ability to use a tablet, these images that we have displayed here can be annotated by drawing on top of them as well as making comments. We found it also useful and necessary to be able to filter those comments just like you would filter comments on a blog as well. What we end up then is a highly linked notebook, because a lot of these table elements that you're seeing there, this is from a chemical biology lab, link back to, I don't know, if you have a PCR reaction, it linked back to the primers being used. So you always can work out, say, which experiments did I use this primer? You can ask that of the work that you've done. So it's a highly linked up, but the structure of the notebook is entirely at the disposal of the experimenter, which is not rigidly imposed. Similarly with metadata, we have the facilities, but we don't impose. This is a social issue because trying to force some of the chemists in particular to do things that we know are the best for them is counterproductive. Showing them and enabling them to do things and learn turns out to be very good. Can I have the next slide? Actually, skip the next slide. Go on to the next. Yeah. So we've got core is that the data is got a lot of metadata in as much as we can infer and as much as we can encourage the user to put in, and it's stored in an easily reusable form. It's basically it's in a database and in an ASCII form. So even if our front ends disappeared, you would actually be able to get the back end data out again. So people don't have to worry about the usual state of academic software, though we are now hoping to make this available as a service and then in discussions with people for that. Have the next slide, please. Just put this up as an example to one of our project students some years ago who was very dyslexic and was very upset about the fact that he could never produce a decent lab notebook. We gave him this tool. He was one of the first to make huge use of putting in pictures. He used his mobile phone to put pictures in there. You'll see it's very bullet point, and if you were able to read the comments, you would see that there are many spelling mistakes. He is a very severely dyslexic student, but he produced a set of reports that his supervisor said was so good and useful, he knew very much more about what this student had been doing in the lab than any of his other students. And the student's comment was, finally, he could produce a lab notebook that looked like he wanted it to. So there is a whole diversity issue here, that we can actually make these tools really appealing to those who are very good chemists, but in this case, or very good scientists, but have some communication issues, and we can get around them. Have the next slide. So if we skip on a couple of slides, next slide please, and the next one. And of course, we've not just got lab-based chemists, but we also have people doing computation. So in our laser work, a lot of computation is going on. We happen to use MATLAB quite a lot of time. And one of the problems is student does some work in MATLAB, produces a figure. You need to change it for a publication. Student has left. How do you find out which data was actually used? Well, no problem, because we automatically blog this stuff. So we have the script and the figures and the data all together. Look there. You can go back and find it and modify it very easily. So not just laboratory experiments being kept track of, but also computational experiments. If I can have the next slide. So what's the impact? High quality record. Even those people who may have used in parallel a written notebook or come back to a written notebook for whatever reason have to admit that the quality of their written notes are very much better having used an electronic lab notebook. Collaboration is much easier to share the data. Improved planning, because people actually think about this and put it down so people can discuss it. Improved discussions. But one of the interesting things, efficiency gain, we can run the project off presentations, but you don't have to produce separate presentations. We just run through the blog script for the last week at a meeting. And the change in nature of the interaction between the students and their professors, we now get chased. Have you looked at my data? As opposed to us chasing them. Can you show us the data? It's there. We can see what they put, and we can annotate it. The next slide. So we can obviously make these notebooks up completely open. It's not necessarily the way everybody wishes to work, but it does make sense if you don't mind your work being open. You can export it out and get a lot of people to interact with your data. And certainly this is a change in view, but as Denning said, it's not necessary to change. Survival is not mandatory. You don't have to adapt to the new world, but it's best if you do. And one of the people who uses our notebook system to great effect in this area, if I could have the next slide. Just to point out, this is Matt Todd in Sydney has used it. Some of the issues that currently why we are hosting his open service in Southampton is that we can satisfy our IT provider, our IT services, that we can look after our system, whereas it took a little while for University of Sydney to agree to that. I believe they now have, and we will be exporting the data back to him. So he has an open notebook on this anti-malarial drug, and you can see some screenshots there of the various different parts of the notebook. You have the next slide. You can see that they've actually constructed some beautiful looking web pages that have come out of these notebooks. They're automatically generated. The Twitter feed goes out to alert people that the new pages, RSS feeds and everything. Lots of images in there. We have been advising them to put in more metadata and put in more links, but you can see they're already following that. They links to other parts of the experiments, links to the material, they put the hazard sheets up and so on. As we build on top of this, more and more of that information can be automatically linked in. But here is an example that anybody can go and have a look to see how beautifully you can construct a laboratory notebook page if you are so minded, and then share it openly with everybody. So the example here of using a blog-based social media approach to engaging in wider collaborations. Have the next slide. That just shows the Twitter feed. Obviously, if you're not running it open, you probably wouldn't put a Twitter feed on. Have the next slide. One of the really important issues is that there's a lot of information that's not made available, not because anybody wanted to keep it quiet, but because there was just not enough time to make it available, not enough structure, not enough results to get it published. And one of the things we've worked with crystallographers is to make it easy to use these approaches with the laboratory notebooks and so on, to publish the data with the context. So it may or may not have been peer reviewed, but it doesn't matter because the context is there. So should you need that data, you can get it checked or you can check it yourself. And this hopefully will make a lot more crystal structure data in this particular case, but data on failed reactions, reactions that didn't work quite as well as you wanted. All that sort of information coming out and being available to share will, I think, increase the quality of the discussion and analysis in the wider community. Have the next slide, please. And this is just an example of the crystals output. If you just go through the next few slides quite quickly, please. It just shows that we actually do have process there. Those diagrams with the circles in them actually allow you to click on the data pathway. Oh, I thought I'd skip that slide for the moment. Just to say that the world is changing. The previous one was about reproducible papers. That's something that's really important. But here we actually have, in some ways, the ability to reproduce experiments, because maybe what you do is to actually give a file that's a 3D construction file that you load to your 3D printer and print out the equipment necessary to redo the experiment. And spaces that are being shared in a very interesting way now. Experiments may be done rather more openly. Whole interaction between people is changing radically. And that's why we need to be able to share the information much better, because the types of people who need to see details of your experiment are a much wider range of people than we would have had before. Have the next slide. Again, just stressing the print revolution, the 3D print revolution, and the fact that Lego Mindstorms are, for example, a way commodity tools and toys can be extremely good for prototyping experiments. And again, you could give out a list of the necessary Lego blocks you need to construct the experiment. Quick Fit was perhaps the same as Lego about 30 years ago for glassware construction. Okay, we have the next slide. So I just want to draw it to an end there by really stressing that it's communicating the context for the data by having collected that content. It's much easier to put the record right at the beginning, get the right information at the beginning and progress there upwards than try and annotate a record afterwards and put in the information. After all, the person who did the experiment is probably the person who knows best what they actually did. They may not know what they ought to have done, but they certainly know what they did. And we need to encourage them to record what they've done and why they did it, and that really rich research record, and have a real narrative about doing experiments. All the work that I described would not have been possible without the UK eScience programme and the various funding bodies in the UK who've contributed both to the chemistry and physics experiments and the computational work, and Microsoft and IBM for funding and support, Southampton colleagues in chemistry, computer science, engineering, maths, iSolutions, our computing service and our library, and colleagues at Bath, Oxford, Reading, Penn State, Cornell, Pacific Northwest Labs, University of New South Wales and University of Sydney, particularly helpful in getting all of this complex work off the ground. And I think one last slide. Was that the last slide?
That's it. That was it.
Okay, so just to say that what we're trying to do there is to move on communication about our experiments into a new world, trying to get everybody involved, trying to capture this narrative and share it. And when you do capture the narrative, people are much more interested in reading it because it's much more interesting to read. Thank you very much for listening.
Thank you, Jeremy. That was a really interesting presentation. What became clear to me during the course of the presentation is that the way of working within a social environment essentially prepares your work for publication, for sharing as you work. So presumably the hope is that this reduces the cost to you of finally preparing both the publication but also the data and the other workflow. Would that be right?
Absolutely. Not only do we see that in actually as we have these meetings discussing how the collaborations, when you get everybody together, there isn't an extra cost to doing that. And then having done that, we have an experiment that's been running for this record running for 3 or 4 years now. We can look back. Some of us might remember, but the new students don't even know what was there. We can search back and get, oh, we did that before, and it's there. And then when we need to move on to the paper, yeah, the data's there. It is that preparation of the data that is a very big deal. Furthermore, we're now coming in the UK, and I think the US is rather similar, under much tighter constraints to keep that record for at least 10 years, if not longer. That means it has to be ingested into some institutional archive or some national archive. Preparing things for ingest is predicted to be at least half the cost of curating stuff. We can slash that cost enormously because if you've got a data file, which is at least reasonably well structured, it's linked to, call it a blog post, which tells you about it. You've suddenly got all the information just right away for most people to be able to read it. So as long as you ingest both the linked post and the data at the same time, you've largely don't have to do much more work. And
that's fantastic.
It also then just encourages people to think about recording entries in their lab notebook, not just for them. And I have students who we occasionally bring back, who've left, and then we bring them back to tell the new crop of research students the statement, I wish I'd recorded this at the beginning in the way I did at the end. Because when they come to write up their thesis, they can't even remember what they wrote in the lab notebook. But if they write it so somebody else can read it, then they can read it. 6 months later, you've forgotten those things. So it really is to help yourself going forward to publication, and then to help others in reading your results.
Jeremy, thank you so much for that.